Okay, now this is the double slotted wing, right? 1, 2. This is during landing and takeoff. You will see something like this. This is the flap support, and this is during the cruising speed. Okay, during the cruising and during the takeoff. Okay. Any question before we continue? Okay, now the angle of attack not only increasing the CL, but it's also increasing the CD. So you can see when you are designing the aircraft, the higher CL you expect, the higher CD you will get. So those things are twin brother with a different attitude. Twin brother, different mom. No. Your imagination is too wild. Right? Okay, so you get also the increase in the CD. Okay? It is always desirable to generate higher lift, but at a lower drag. That's why you are generally given the ratio between CL and CD, and you want it to be as big as possible. But again, when you are not doing it properly, you will get into the stall region, where the lift suddenly goes down and your drag suddenly goes up, right? Because your wing now is like this. Rather than having a lift, this wing now provide you with huge drag. So your aircraft will become a loosened kite, right? So that's the thing that we need to. Okay. Okay. What else? Okay. Now, any one of you do jogging in the morning? Okay, when you see when you do jogging in the morning, or no need to do jogging, but you see the aircraft take off from the Penang or from the Ipoh, then you see in the oval park there, you will see a trailing white thing that has two. That is come from these trailing vortices. This trailing vortices is because, now you see, your aircraft, the velocity over here is smaller than the velocity over there. Okay? Which means the pressure over here is higher than the pressure over there. That's why you get the lift. Correct? Got it? Now the problem is, what happened in the wingtip? You get here, at the bottom of the wing, the velocity is lower, the pressure is higher. On the top, velocity is higher and the pressure is lower. At the tip, when there is nothing, what happens? The pressure from down there will goes up, right? The wind will goes up because the pressure here is higher. It goes up, but when it goes up, it will just goes into here, the region where the velocity is higher. Now, when it goes up, then the velocity over there is similar to velocity over there because there is no effect of the wing. The pressure will be the same with that, which is the atmospheric pressure. So what will happen with this air? Right? You do not like your friend, you go to another friend, but this friend also do not like you. You just do this, rounding and rounding and rounding and rounding. Right? I go to you, you do not like me. I go to Miss Sharon, no. Then I just go there, here and there, here and there. Okay, like our friend who cannot join this group, cannot go to that group. Just like rounding and rounding and rounding. Those things will generate the so-called trailing vortices. Okay, so this is what you see. Anyone see that?
Yes.
That one is not the trail of the rocket, no. This one is the trail of your wing. When you take off. Where you get that white color thing, what is that white color? Is the fuel. If it is fuel, you can burn. Huh? Vapor. It is a water vapor that is condensed due to the low pressure. When you have a higher pressure, your boiling point will be higher. When you have a lower pressure, you will have a lower boiling point. Right? Anyone has a pressure cooker? Or your mom has Noxa or Philips pressure cooker? Why it can make those bones become soft? Is because you have a higher pressure. When you have a higher pressure, when you close it, you have a higher pressure, then you can reach a higher temperature without having the phase change. Because if you have a phase change, doesn't matter how big your fire, the maximum temperature will be 100 degrees. Right? You will not be getting even higher than that. The only thing will happen is you will change from liquid water into water vapor. So if you want to get higher temperature, what will you do? You keep it pressurized. When you keep it pressurized, you can reach a higher temperature. Higher temperature means you can break up more protein. So the protein will be just like it will be chopped. That's why you get that. Okay? Now, in a real condition like this, your water is in a vapor region, in a vapor phase. But if you decrease the pressure, it will condense. Those condensed water become those white color. Because water vapor is transparent. But if you have water liquid, it is more opaque. Up to you. Okay? My pronunciation is not good. Anyway. Okay, so that's why you get this white trailing fog. Okay, clear? Now, believe it or not, this thing contributes to big percentage of fuel consumed by the aircraft. This thing, this rolling vortex trailing. That's why nowadays the aircraft manufacturer try to minimize it as much as possible. Okay, because it will burn more fuel than when you don't have this thing.